Have you ever noticed that your screen time drops during exam week or your power bill spikes during the summertime? That's not just random, that's a time series. Time series data is information collected over regular time intervals. Today, we'll learn how to read that data and identify the story that it's telling. So time series data is a set of values collected over time, whether that be days, months, or potentially years. And in this case, the order matters. If we mix up the order of the data, the meaning disappears. Time is always on the horizontal axis, and the data points are usually connected by straight lines. Talk about trend. So the trend shows the long-term direction of the data. If it's an increasing trend, for example, here, you can see that over time, values rise. Potentially, we might have a decreasing trend where over time the values fall. Or maybe we'll have no trend at all, where the values may fluctuate, but there's no clear direction that the values are headed in. Secondly, we'll talk about seasonal variation. So seasonal variation is a regular up and down pattern that repeats in a cycle. For example, retail sales might spike every December. This pattern usually occurs consistently and over the same time period. Just keep in mind that usually it's in periods of 12 months or less, and the seasons may occur over a cycle. For example, you might have 7 days in a week, or 4 quarters in a year, or 12 months in a year. The easiest way to spot how many seasons there are in a cycle is to search for low points, or troughs, or high points, or peaks. Once you identify one of these peaks or troughs, you need to count the number of intervals until you reach the next peak or trough. So for example, if I start at this trough down here, I can count the intervals 1, 2, 3, 4 until I meet the next trough. If I started at the peak, I would go 1, 2, 3, 4. And I can see that there are 4 seasons in a cycle in this given example. If you're asked a question that asks you to discuss seasonality, you need to remember a few important points. So first of all, you need to mention the number of seasons in the cycle, for example, 4 quarters in 12 months, and identify specifically where the low and the high points occur in each cycle. In this case, we'd say that the low points occur at March each year, and the high points occur in December of each year. It's important to note as well that you want to describe it in the context of the question that's given. So here we look at quarterly retail sales in Australia per capita. The third thing we'll talk about is irregular fluctuations, which are also known as noise or outliers. So in this first example here, you can see that there's no clear trend. However, there is a very clear outlier in the data. These are random and unpredictable changes in the data, and they're not part of a trend or any seasonal pattern. And they could be due to one-off events. So for example, a sale, maybe a natural disaster, or potentially something that's just unexpected. In this second example here, you can see that the context is the employment in Texas over the years 2014 to 2024. There's an increasing trend in the data. However, at this point right here, which lines up with the COVID-19 pandemic, you can see that there was a huge drop in employment during that time. This here we would call an irregular fluctuation, as it doesn't necessarily follow the general trend that the data exhibits. It's also worth mentioning that there's a difference between data that has seasonal nature and data that is cyclical in nature. Cyclical data tends to follow a pattern of ups and downs over time, but they don't line up with a specific time period. So in this example here, you can see that if I started at a trough, this one here, and I went up, up, down, it doesn't follow the same pattern up, up, down. It goes up, 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 down. And that tends to go randomly throughout the entire time series. This particular graph would be a cyclical graph rather than a seasonal graph. So here you can see a typical exam question that you may be given in a non-calculator section. And the context of this is about the number of gas bottle refills over a period of 3 weeks in a service station. The first part of the question asks us to plot the data points for 2 marks. And usually to get the full marks there, you would need to get at least 4 points correct. And the second mark would be given for having all points correct. But the thing that's most important here is the second part of the question, which asks us to describe trend, seasonality, and any other features of the time series plot for 3 marks. So the behaviors that the examiner is looking for here would be correct mention of trend, which in this case is an increasing trend. That would give you 1 mark. Second thing it wants you to talk about is seasonality. And remember before how I mentioned when discussing seasonality, we want to talk about 3 things in particular. So how many seasons there are in the cycle. In this case, we have 7. And then specifically mention where the lows and highs occur in the context of the data. So the lows occur each Friday and the highs occur each Sunday. That would get your second mark. For the third mark in the question, you're looking for any other features. And it's really clear here that in this time series plot, there's a clear outlier. In the context of the data, we'd say that there's an apparent outlier on a Wednesday of week 4, and that would give you a third mark. All right, so let's recap. So essentially it's just data that's tracked over time, where time is always on the horizontal axis. Points are usually connected with straight lines. You can think about the components of time series data in 3 ways. There's maybe a given trend, whether that be increasing, decreasing, or no trend. You need to think about seasonality, whether there's regular patterns and cycles. And third, we talk about irregularities. So that might be noise or outliers in the time series data. In the next video, we'll learn how to smooth the data using moving averages to better identify the trend.